at an angle of 50 degrees above the horizontal with a speed of 35 meters per second, and it just clears this outside fence, which is at the same height that the ball was hit. We want to know how far away, or our distance in the x direction, is the fence from where the ball was hit. So I plugged in some numbers that we already know. We know the distance in the y direction is 0 because the ball is hit and gets to the exact same height, so that would be no change in y displacement. And the acceleration is negative 9.8 meters per second squared, and the distance in the x direction is what we're trying to find. And we have an angled problem, so what we need to do is we need to solve for this right triangle that I actually drew right here. I'm going to draw it again a little bit larger so you can see it. The actual velocity of the ball coming off of the bat is given in the blue line, and that's 35 meters per second. But we need to figure out, well, how much is that to the right, so our x velocity, and how much is that going up, which is our y velocity. So from here, we just plug in our angle, which was 50 degrees. And we're going to do our basic sine and cosine stuff in order to figure out what the x and the y happen to be. The x is the adjacent side, so that's going to be the cosine. So x velocity is going to be the cosine of 50 degrees, and that's going to be multiplied by 35 meters per second. And when I plug that into my calculator, my x velocity, I get a speed of 22.5 meters per second. I'm going to do the same thing with the y, but now I'm using sine because it's the opposite side. So the sine of 50 degrees times 35 meters per second gives me a y velocity of 26.8 meters per second. I'm now going to plug that information back over here. My y velocity was 26.8, and my x velocity was the 22.5. Now I'm going to solve this like we do every projectile problem. I'm typically looking for something in a dimension, in this case the x, that I don't have enough information to directly solve. So I've got to find time in my other direction and plug it in to get what I want. So I'm going to pick the equation that will help me solve for time in the y direction that does not have VF, since I don't have it and I don't want it. And that would be the d equals v naught t plus 1/2 at squared equation. Something which makes our lives a little bit easier is I know that my displacement in the y is 0, so this whole term d is going to cancel, leaving me with 0 equals v naught t plus 1/2 at squared. That'll save us from having to do the quadratic formula in this problem, because now I'm going to try and solve for time. So I'm going to move this term, the v naught t, over to the other side. I get negative v naught t equals 1/2 at squared. And I've got t on both sides. I can cancel the squared with the one on the left. So I just have negative v naught equals 1/2 at. Solving for time, I'm going to divide the 1/2 a over, which turns into 2 v naught up top over a. Plug in my numbers and I get the, don't forget to keep the negative, very important. So negative 2 times 26.8 meters per second divided by negative 9.8 meters per second squared. And when I plug that into my calculator, I should get a time of 5.47 seconds. I can now plug that in over here, the 5.47. And I can very easily solve for my distance now, because d equals v times t. I just have to multiply them together. So 22.5 meters per second times 5.47 seconds. And I find out that the outfield wall is 123.1 meters away from home plate.